good?
Mm-hmm.
Alright, so we'll look at platonic solids. A platonic solid is a shape that has all the faces are the same and all vertices are the same. So usually when we talk about platonic solids, we're looking at three-dimensional shapes. That's what I talk about most of the time. There's 5 of them. There's the tetrahedron, the cube, the octahedron, the icosahedron, and the dodecahedron. And they all have a certain amount. So the cube, for example, is the most popular, the most used. It has 6 faces, and each vertices, that's exactly the same stuff going on with it. And that's the same with the other 4 as well. But you might think, well, could you do that in 2 dimensions or 4? Yes, you can. In 2 dimensions, instead of having all the faces and vertices the same, you would have all the vertices and edges the same, because edges are kind of like the 2D equivalent to faces. So you could have a triangle, all the edges are exactly the same, the vertices are the same. You could have a square, pentagon, hexagon, heptagon, and you can actually keep going, and there's an infinite amount of platonic solids in 2D, all the regular polygons. However, in 3D, they have to, also these platonic solids, they have to be made of platonic solids from lower dimensions. So the only things available for 3D platonic solids are those infinite 2D platonic solids, and there is a lot of them. So there's the triangle, the square, and all that just keeps going on and on and on. So you've got all of those things, and yeah, so you can make 5 from those. 5 platonic solids, 3D, those are the ones we know best. What about 4. So in 4 dimensions, here's a fun little game we'll do. So 4 dimensions, we can only use platonic solids from 3D. So there's 5 platonic solids to work with, and there's a certain amount, a fixed quantity, not infinite, but not 0, of platonic solids you can make in 4 dimensions. And how about everybody put in the chat how many platonic solids you think there are in 4 dimensions that you can make. Just give you like 10 seconds for that. Alright, so we've got a 6, we've got a 1, and alright, we've got some good guesses here. 4 is actually a really good guess as well, but the answer is actually 6. So here's the thing. We can have analogs of each one of these. So we can have an analog of a tetrahedron. Just like a tetrahedron is an analog of a triangle, we can use 5 tetrahedra and we can make this thing called a pentahedron or something. Let me show it to you here. Right, 5 cell. So here it is. Here's a cross section of it. You can look at different cross sections of it. So it's really confusing at first, but you get used to it if you look at it a lot. It's a really interesting shape.
Maybe slow it down a little for them.
All right, so here. Oh, let's see how I'm moving the slider along. And then we've got the tesseract, which we already talked about. And then we've got, basically analogs for the other ones. We've got a 150 cell, which is made of dodecahedra, and it's like this big giant thing, and that's really interesting. And we've got these other 3, and we have a bonus one. So this one doesn't have a 3D analog, so it's kind of like if you had a cube and then you put tetrahedra on the outside, but it's in 4 dimensions, so it actually makes a platonic solid. But it's really hard to visualize because it's not like anything else. Now, there's this really cool video I'd like to show you. There's a question. Yeah, I explained that. So the diagrams, you connect the vertices with the edges for all dimensions.